comfortable.
Kata sensei. Prof Idota Genki sensei.
Yes, yes. She's so busy because she becomes the vice dean in October.
Oh, really, sensei? Oh, okay.
Yes, yes.
Please my
Yeah.
regard to Prof Idota sensei.
Yes, yes. I send your message to Professor Idota.
Isma, jam berapa kita mulai? Mungkin bisa mulai, Nek. Isma,
Yeah.
maybe we need to start because already 1:33.
Okay. Good afternoon and warm welcome to all the participants of the Hasanuddin Animal Science Summer Course 2024. It's a great pleasure welcome you all to the third day of our summer course. Allow me introduce myself. I'm Isma Ulfia Asis and I will be the moderator for today. We are honored to have two excellent speakers with us today who will share their expertise on the topics. Allow me introduce our first speaker, Professor Yasuyuki Ishii from Miyazaki University, Japan. He will delivering a presentation on grassland science. And our second speaker is Dr. Kannika Umpuch, M.Sc Ph.D. from Valaya, Alongkorn, Rajabhat University, Thailand, who will be presenting on forest crops. Before we start, let me give you information that after the presentation, we will open the question and answer session. All the participants who have a question, you can write it on chat box or raise your hand if you want to ask it directly. And also, please all the participants to mute the microphone while presentation session. We will now begin with our first speaker. Prof. Ishii is highly respected figure in field of grassland management with a vast background in research and teaching at an international level. And his insight about grassland will provide us valuable knowledge for all of us. Please join me in welcome for Yasuyuki Ishii to present on grassland science. Prof. Ishii, time is yours.
Thank you very much. Thank
Okay.
you very much, Miss Isma Uru here as a moderator for today's section. I will share the PowerPoint. Sorry. I'm sorry. Wait a minute, please.
It's okay. Take your time.
Share. Yeah, this one. This. Okay. Can you look at my slides?
Yes, we can see it.
Okay. Thank you very much. I'm very proud of being here to have a speech to the students and professors in Hasanuddin University as a Hasanuddin Animal Science Summer Course 2024. My speech title is Characteristic of grassland science, an approach to grassland-based animal production. I'm majoring in forage crops, therefore, most of the research are conducted for forage production. So, this photograph shows the harvest of grain maize as a replacement of concentrate. So this research is to cope with the shortage of imported concentrates. And the right-hand photograph shows the monitoring of grazing behavior of beef cattle. This is to establish the grassland-based animal production. in our side, southern Kyushu, Japan. Today's content are these three chapters. The first chapter is a characteristic of animal and grassland sciences in the case of Japan. So most of the characteristics are similar between Indonesia and Japan, but I have I have some comment on the specific characteristic in Japan or in southern Kyushu. First slide show the location of Miyazaki. This is a map of Japan. The Miyazaki is located is south eastern part of Kyushu Island. And this figure 1 shows the agriculture product from each animals or each crops. So beef cattle produce around 21% of agriculture production in Miyazaki Prefecture, and dairy cows and swine and poultry. Therefore, from the beef cattle to swine, 65 of agricultural products are from animal husbandry. Therefore, animal husbandry or animal production is a major agricultural industry in our sites. However, there are some statistics for feeding animals. This table shows the demand and supply of feeds to domestic animals, to livestock animals. Increase in feed demand in the last half century means the increase in livestock animal number in Japan. However, the domestic feed supply to animals maintained to be constant around 6 million tons in Japan. Therefore, increase in livestock animal numbers was supported mainly by the increase in imported concentrates in the last half century. Therefore, feed sufficiency rate decreased consistently in the last half century, almost halved, almost to be half. However, the situation of self-sufficiency rate of cereal foods are different between developed countries like G8 members. Developed countries like G8 members such as United States, Canada, Germany, France, Italy, United Kingdom, all have high self-sufficiency rate, 100, which means that they are also developed in agriculture, excluding Japan. For the case in United Kingdom, the self-sufficient rate almost 55 years ago, the rate is lower than in Japan. However, United Kingdom continuously try to increase to 100. However, Japan decreased continuously in self-sufficiency rate, self-sufficiency rate of cereal foods by the import of concentrate from foreign countries. This figure basic production harvesting avenues in forage production. There are two avenues. One is the below pathway. One is the upper pathway. To reach animal production as the economic values, one avenue is by forage crop production in hayfield and harvested by machinery and fed to cattle like this. And the upper part is the grasses are cultivated in pastureland or rangeland, and the harvest was fed by grazing animals, and animal production can be achieved. Therefore, economic value is evaluated by these animal products. Grass or forage production is a bypass production to the final economic values. From this, there are several statistic data for understanding the Japanese livestock production. The first one is the labor hours to produce grain crops. Even in grain maize production, grain maize utilized for feed needs least labor hours among the other cereal production. Therefore, grain maize production or forage crop production is estimated as extensive farming compared with the intensive farming such as rice cultivation. This figure shows the steps of farming in several grain crops. For the case of rice cultivation, nursery should be prepared, and tillage and ploughing of the lowland are necessary, and transplanting of nursery by machinery is also essential, and weeding by herbicides or machinery. Water management is quite necessary to maintain the root activity of rice crops. And before harvest, drying soil is necessary for operation of harvester. And pest control also necessary several times. And after the harvest of grains, the hunting and drying processing are also necessary. However, in the case of grain maize production, manual and lime application and tillage and ploughing of the land are necessary. However, after sowing of grain maize, herbicide supply is necessary at the fourth or fifth leaf stage. Then harvest can be completed. Therefore, cultivation process is simplest in grain maize production compared with other cereal production, which is the main reason for extensive farming in grain maize production or forage crop production. This is a change of acreage of uh, uh, several lands for agriculture. Total acreage decreased from 6 million hectares to 4.4 hectares in the last half century. Also, the acreage of paddy field and upland field and orchard are de uh, decreasing, have been decreased in the last half century. However, acreage for pasture increased 4.3 times as much as that in 1965. Therefore, in the last half century, agricultural acreage decreased in Japan, except for pasture, uh, which means that pasture can maintain agricultural land for production activity. This photograph is brought from Dr. Satoru Fukagawa in Nagasaki Prefecture. He conducted the grazing beef cattle on the abundant lowland field, abundant fields. Before grazing, the land is covered by bush, and by grazing, the original uh, uh, lowland field is comes out. Therefore, forage crop production of pasture is uh, less sensitive, extensive farming. Uh, However, pasture can maintain the agricultural land for production activity. Next is a problem and solution for forage production in Southern Kyushu as well as in Japan. Second chapter. Uh, this statistic shows the uh, uh, maize import from foreign countries. Major concentrate for animal feed is maize, which is principally imported from United States, followed by Brazil and Argentina. This table shows the export of maize by the major producing countries. The unit is million ton, so the largest exporting countries, United States, followed by Brazil, Argentina, and Ukraine, etc. The total amount of exported maize is uh, uh, 200 million ton, 200 million ton. Therefore, Japan import almost 6% of world total maize export. Uh, uh, However, as you know, there is a conflict of feed grain export from Ukraine ports to the Europe. Was happened uh, against Russia. Therefore, this situation is so unstable. This station is in unstable conditions. This figure shows unstable conditions. From 2002 to 2022, export of maize from United States is decreased 30% due to the production decrease by drought. However, when United States maize production decreased by the adverse climate, the export from United States decreased, even though the national domestic demand was maintained. In this case, Japan needs to increase the import of maize from the other countries such as Brazil and Argentina. However, this situation, this escape policy is now questioned. This figure shows the price of concentrate for daily cow production. Concentrate price increased so rapidly by almost 50% in these 2 years. The same situation was happened to compound fertilizer price. Fertilizer price increased so rapidly in these 2 years by 50%. Therefore, Japanese government promoted to process animal manure to pellet because pellet making by the pellet making, manure can be delivered widely from the producing areas to the consumption areas within the country. In addition, several costs such as electricity, agricultural materials increased so rapidly in the recent years. However, price price between self-sufficient harvest and imported hay are quite different. This is a case for hay making in national total and in Hokkaido. Hokkaido is here. Hokkaido is a major uh, animal husbandry area in Japan. And the area except for Hokkaido. And the price of imported hay at the basic TDN kilo at the unit of TDN. So the price was cheaper in self-sufficient hay production compared with imported hay. The same situation was applied to silage production. For making silage, there are several agricultural materials such as plastic film and uh, to the press for storage of silage. Therefore, the cost increased compared with hay production. However, domestic harvest production or self-sufficient harvest are absolutely cheaper than the imported hay. This slide is the specific example to understand the importance of harvest. This slide talking about the imported hay. However, this slide deals with organic dairy farming. USDA certificate organic dairy products means these conditions. Cows and calves are fed 100% organic feed. Other crops, hay and pasture are grown without the use of synthetic fertilizer such as compound fertilizer or chemical pesticides. GMOs are strictly prohibited. All animals must have access to the outdoors or in the favorable growing conditions have access to pasture. This figure shows organic roughage licensed in United States. However, these licensed organic roughage are so expensive. Therefore, this is a combination between dairy company and private ranch. Imported organic roughage is sold to dairy farms at a comparable price with the ordinary roughage by a dairy company. And organic ranch produce milk, and milk is transported to milking factory registered as certificated factory by the U.S. certificating organization. and produced milk is sold at the ordinary price to dairy company. And dairy company produced organic milk and yogurt. And this as a high brand milk and yogurt at a variable price, and then some consumer would like to purchase this organic milk and yogurt. The same case was conducted in Tamana Farm Kumoto Prefecture. This ranch adopted as year-round grazing on semi-natural pasture. However, this pasture was supplied no chemical fertilizer or no concentrate was fed to dairy Jersey cows. Therefore, these organic milk and cheese are sold at variable price. High brand milk was bought by restaurant chef. This is a newest movement by Japanese government. Under the present self-sufficiency rate, how should we support the food energy supply? How should the farmers support the food energy supply to Japanese consumers? So this is a list of breakfast, lunch, and dinner tables. The below shows the additional meals. Quite few supply rate of animal products to maintain calorie supply. Therefore, new legislation of Japanese government to increase food supply under the emergency happened by the Ministry of Agriculture, Forestry, and Fisheries of Japan. The self-sufficient food ratio declined to 38% under the emergency or pandemics of infectious diseases such as COVID-19. When food import from foreign countries will stop, then how does the national calorie supply maintained by Japanese farmers? Therefore, legislations may include the governmental order to farmers who must cultivate root tuber crops such as sweet potato or potato, or instead of growing ornamental flowers. This legislation was established as Basic Act on Food, Agriculture, and Rural Areas in June this year. We have, I have almost another 10 minutes to explain this newest research. Silage quality and feeding preference of late summer sown pearl millet in southern Kyushu. This manuscript was accepted by Grassland research. So this paper will soon be published in this journal. This photograph shows the heading of pearl millet in early November. However, this pearl millet has high moisture so it's difficult to make silage. However, in early January, moisture decreased to 50%. Therefore, direct cut and land-based processing was conducted after harvest. And the most important things, in early January or February, this season is a bacon cropping due to cold climate. The minimum temperature declined below 0 degree. Therefore, forage plant cannot grow. Therefore, no cropping is necessary at this time, at this day. And the weather is so fine, so land-based silage processing is quite easy to do. Background for this research: under the climate change, escape from typhoon damage in the summer season is essential by cultivating crops. Over the past 2 decades, typhoon frequency from July to September reached over 100%. Therefore, lodging risk of maize increased by typhoon visit. Permit is gone like this. However, this permit has high moisture. Therefore, pre-drying is necessary. However, this is unrealized. Therefore, permit is now only used for direct cut and feeding to breeding beef calves by small product farmers. So I would like to try to introduce permit to large-scale livestock farmers. Background to extremely late heading permit cultivar has a basic vegetative potential, even under the late summer sowing conditions. And from September to November, effective temperature is calculated at 900 degrees. So this temperature condition is sufficient climate for cultivating palmate in this September to November. And in the 21st century, the mean temperature in September to early October rise, and mean temperature in December drops. So this situation is quite reasonable to apply this permit cultivation sown in early September. The objective of this study is to determine growing potential and dry matter percentage change and the harvest of forage for silage processing in late summer sown pearl millet. The sowing of maize was conducted by this sowing machine and applied to this field. The area is like this, almost 0.5 hectare. And this is the change of growth parameters. Plant height reached to 1.5 meter. Tiller density reached to 100 per square meter. And dry matter yield reached to 900 grams per square meter. This yielding level is almost double as the case of sowing Italian ryegrass in September. So dry matter production is so high. And we measure the daily minimum temperature by this data logger at the field. And calculate the cumulative frosting temperature below 2.2 degrees Celsius, like this. And we put the change of dry wet percentage. Dry wet percentage increased after the frost falling. Dry matter percentage has a linear regression equation against the cumulative frosting temperature. This figure shows the change of crude protein content. Crude protein content almost maintained during the frosting season. However, severe frost led to increased ADF content, acid detergent fiber content, which is indigestible fiber components. Therefore, increase in ADF content led to decrease in digestibility. So the processing of feed is like this. Roughage is harvested and making landbale silage. And from the landbale silage was stored 3 months and get a sample by Dr. Ishii. And this silage was fed to animals. And this table shows the silage quality. Silage pH was moderately higher than 4.8, and lactic acid content was lower than 1.6, but no butyric was produced, therefore leading to good quality silage. This figure shows the preference of Japanese beef cattle. Preference of forage per millet tended to increase with the trial repeated, compared with Italian ryegrass hay. In conclusion of my speech, a characteristic of animal and grassland science were described concerning agricultural economy in Miyazaki Prefecture. In the aspect of food security, self-sufficient harvest production becomes more essential for livestock production in the recent situation. A steep rise in concentrate compound fertilizer price was a risk to grass and animal production. And the topic of organic dairy farming was explained. The new Basic Act on Food, Agriculture and Rural Areas by Japanese government was also explained. Stable and less intensive silage processing system was developed in the vacant farming season in Miyazaki. Thank you very much for your attention. This is a photograph with senior student at the graduation ceremony. That's all for my talk.
Okay, thank you very much, Professor Yasuyuki Ishii, for the comprehensive and very insightful presentation today. And now we will move to the time for questions. So For all the participants who have a question, you can write it on chat box or you can raise your hand in Zoom meeting. So I will let you to ask directly to Professor Yasuyuki Ishii. Please.
Thank you very much.
There is any question? So while waiting the question from the participant, I have a question, Prof.
Yes, please.
On your presentation, you said that livestock rise on the pasture without any chemical in their feed would produce better and higher value milk. How do you manage feed to meet the livestock nutrition needs when they grazing? So how to meet it, the nutrition to the livestock when we grazing?
That's a big problem. That's a big task for us to cope with the nutrition by concentrate and animal nutrition by grazing. So in my idea, to, in my idea, tropical grass like this has a lower nutrition values compared with concentrate. Therefore, it is better to select the animals for applying grazing management, such as adult breeding beef cows needs less nutrition value compared with fattening beef. Or before selling fattening beef, they need concentrate feeding for several months. But before selling to the market, beef cow, fattening beef cow can be applied to this grazing management. This is my idea for
Okay, thank
using
you.
tropical grass grazing management.
Okay, thank you, Prof. Yasuyuki Ishii. For all the participants, we still have a time to question and discuss with Professor Yasuyuki. If you have a question, you can chat on the chat box, or maybe you can want to give a question directly. You can turn on your microphone. There is any question?
Could I ask some question?
Okay,
Yes.
please. Yeah,
So
please.
thank you very much,
Thank you very much.
Dr. Wakan.
Okay. Thank you very much for the opportunity. Good afternoon, Prof.
Good
Yasuyuki.
afternoon. Thank you.
Good afternoon. I hope you have a great day today. It is quite fascinating material for me because it is also my basic of research. For your information, Prof, right now I'm with Mr. Ahmad Wadi. He is my senpai in my university.
Oh,
okay.
yes.
I would like to ask some question about maybe it's like some suggestion from you for my research.
Yes.
And then in your presentation, you said that
Yes.
You sown the permillet at the late summer. I think it's on November, and then you you harvest it at the early January, and
Yeah.
then the grass must have through the winter season, right?
Yeah. Yeah.
And also it under the frost phase at the winter season, it
Yeah.
should be affect the physical and the nutritional condition of the grass
Yeah.
and then it also prevent the plant to growth in especially when the grass at the early phase of the growth. When we sown the grass at the late summer,
Yeah.
I mean, if we plant the grass, if we sown the grass at the late autumn, so it nearly winter, it will affect the winter season will affect the growth pace of the grass, right?
Yes. Yes. So, in my research, tropical grass was sown in late summer. However, normal cropping was conducted for cool season grass sown in autumn.
Okay.
However, this cool season grass is difficult to harvest it in January because the growth rate is so low compared with tropical grass in autumn season.
Okay. Can I continue my question, Prof?
Yes, please.
Yes, thank you very much. Okay. If we talk about the tropical grass,
Yeah.
I want to explain the climate condition in Indonesia, Prof. Right now, especially in South Sulawesi,
Yeah.
we are facing the longer dry season than 2 years ago. So
really?
it difficult to us, especially for me and the smallholder farmer to begin to plant the grass for the cattle, for the animal. So
Yes.
could you give us some suggestion for us to manage and to keep the production of our grasses or tropical grasses in such as such climate that we're facing right now?
Yeah.
Thank you very much, Prof.
Oh,
Thank you
thank
very
you
much
very much.
for this.
Thank you very much for your questions. So,
Yes.
in this longer dry season, it is difficult to grow tropical grasses. However, leguminous fodder trees can be grown due to deeper rooting system. Therefore, it is recommended to intercropping of tropical grass and leguminous fodder crops. Then, when the dry season starts, tropical grass may be dead. However, leguminous fodder crops produce browse. Then these browse can be applied to cattle, to animals. This is one way to escape from the drought season.
Okay. Thank you very much, Prof. I hope your suggestion will help us to face this condition. Thank you very much.
Thank you so much. Thank you much for your question.
Thank you, Mr. Wakano, for the question. And also thank you for Prof. Ishii for the since discussion and informative answer. And maybe for the next session, we will move to our second presentation.
Yes, yes.
And maybe you can unscreen your cam. Thank you. Now it's my pleasure to invite Dr. Kannika Umpuch. Are you here?
Yes, I'm here.
Okay, Dr. Kannika Umpuch will be present her presentation about forest crop. Maybe you can share your presentation.
Okay.
Okay, because we will move to yours. And Dr. Kaninka, time is yours.
Can you see it?
Yes.
Oh, okay. Thank you. Let me set my Good afternoon, Professor Ishii, and
Good afternoon, Dr. Kannika. I'm very proud to listen to your lecture.
thank you so much. Okay, I will start my presentation first. Let me set my screen for a while. How to? Sorry. And okay, my research article is average daily gain of the male dairy calf. I don't know why it's automatically changed the slide. And the daily gain of male dairy calf between grazing and TMR system in Thailand. First of all, the introduction, like the same in the Japan, during the dry season of every year in Thailand, there is always a shortage of the fresh crop in Thailand, starting from the beginning of winter to the beginning of the summer of every year. The main cause is that during that period, the temperature and environment are not suitable for plant growth. In addition, during that period, the forage crops are in the flowering stage, resulting in a decrease in quality. Even if water is provided, the grass quality does not improve and affecting the animal production due to inconsistent forage use throughout the year. This can be seen from the study by letting cattle cows graze on purple guinea grass in Phetchaburi province in 2008. It was found that purple guinea grass use decreased between November and January because this is the period when the grass stops growing leaves and stems. However, inflorescence to produce seeds are growing. As a result, the weight gain of the tested dairy cows is lower than other periods of the year. However, proper grass management can help increase the quality of forage grass even in the dry season, such as suggested by Professor Sayantasi, such as cutting the grass to the level where the tips of the shoot that are inflorescent can be cut off, allowing the next buds to sprout, which consists at least leaves, 2 to 3 leaves, will help improve the quality of this grass. First, okay. First, we focus on the napier grass. The Napier grass is considered a fodder grass that is popular among farmers. In addition, it is a grass that has been promoted by government to be produced for animal feed. And Napier grass is a tropical grass that gives the highest yield per area, as you know, suitable for production in limited area. And it can be used in many ways, such as letting animal graze, cutting fresh, or cut and carry system, or using it as a silage, depending on the type of grass, such as the dwarf napier or giant napier. In this picture is banana napier grass. Common napier grass is a tall type or a giant napier. It's suitable for silage making and cut and carry system. And the left and the right side is a mullet napier grass. It's a dwarf napier that I will talk about the next. The next slide is a dwarf napier grass. It is considered a native grass of America. It was brought to Thailand for tested by the Dairy Farming Promotion Organization of Thailand, or DPO, and the Department of Livestock Development, or DLD. The glass imported by DPO was jointly tested by Professor Dr. Sayantasi from Gasusai University and Professor Yasuyuki Ishii from Miyazaki University, Japan. And it was named Morlek napier grass. The name Morlek napier grass because to avoid confusion with the breed imported by the DLD, which has different growth characteristics that we call moth dwarf. Morlek napier grass is a species that flower late. The leaves are large and have a little hair. The leaf tips point straight, making the leaf canopy point straight too. It has a strong root system and underground rhizomes. The nodes that are close to the soil surface have roots growing out of the nodes of the stem. And the inflorescences are 10 to 22 centimeters long. It flowers only once in late November to December in Thailand. And it is considered a drought-tolerant grass and is suitable for letting animal graze in a rotational grazing. The study found that Morlek gave an average dry weight yield in the rainy season. Dry matter yield in the rainy season in Thailand start August to since August to the late October. At 3 months, cutting edge of 1.5 tons per rye, and in the cold season, November to February, of 0.5 tons per rye. Next, we talk about Pak Chong Wan napier grass. Pak Chong Wan napier grass is a grass in the giant napier group. Is a crossbred between giant napier grass and permillet grass. It is about 4 meters tall when fully ground and has a strong root system that spread in the soil and absorb water and fertilizer well. The stem and shape are upright. It is propagated using cuttings and considered a potential forage crop in terms of both yield and nutritive value. The research about the Pak Chong Wan napier grass, Kanha et al. Reported that the suitable age of Pak Chong Wan grass should not exceed 45 days, which will produce good quality grass measured by crude protein content and dry matter digestibility. Therefore, it is suitable for raising animals, especially ruminants such as dairy cows, beef cattle, buffalo, goats, and sheep. Currently, the Department of Livestock Development has supported and promoted farmers to plant it throughout Thailand, including disseminating into other countries. For the current research of the DLD that has been published, there is only the production of pak chong wan silage for use as animal feed for both ruminant and non-ruminant. However, in terms of releasing animals to graze, there has been no such report. And the next part, we will talk about the TMR or total mix ration. TMR is a feeding management that the method that requires mixing raw feed with a concentrate in a specific proportion according to the formula that allow animals to eat in every bite that meets their needs consistently and allowing them to eat throughout the day without having a graze in a pasture. In this picture is a heifer eating the TMR feed, and they stay in the freestyle barn 24 hours. In terms of releasing dairy cows to graze on pasture, it was found that past research in Thailand has not found any studies of releasing dairy cows or other ruminants to utilize forage crops during the dry season in the field crop. November, December, and January in Thailand is a dry season, cold and dry season. There is only grazing during the rainy season in Thailand, starting around August to end of October, and closing the field or closing the pasture during the dry season, or grazing on grass field during the dry season, but it can providing water to the field. Therefore, although season and climate are uncontrollable factors, if the grass plots or pasture can be managed to be utilized continuously throughout the year, the problem of lack of fresh raw feed for ruminants during the dry season, especially from early winter to early summer, should be alleviated. Thus, the objectives of these studies were to the first study the ADG of male dairy calves during the dry season between a grazing system and a normal system implemented by the DPO, which is feeding them a TMR system. And the second one is to study the yield and nutritive value of two napier grasses. We choose pak chong wan because it is a high-yielding grass, and there's no research on grazing now in Thailand. And Moklek napier grass was selected because it is tolerant to grazing and drought in Thailand. Next part is a material. We talk about animal, grass, and pasture. We use the 9 male crossbred Holstein Friesian calves, 8 months old, and they have Holstein Friesian blood at 76 to 98%. We use the cow from DPO. Before testing, they were given anti-parasitic drugs, external parasite drugs, and vaccinated against epidemic diseases according to the program. And dairy calf rearing system of DPO in this picture stay in stall barn 24 hours plus and gave they receive a TMR. The TMR made from hemiglass silage mixed with the concentrate feed. The second material is grasses. We use, as I said, we use Moklek napier grass and pak chong wan napier grass. And the experimental site, the experimental pasture I used was Hemugini grass pasture. The area about 1 hectare of the DPO at Saratburi province, Thailand. This is the experimental site also. This is a pasture that we have conducted the research. Next, the method pasture experiment, animal management แล้วก็ and data collection. Pasture establishment and management. First, we preparing the experimental area by plowing twice to prepare the soil and clearance the land. And next, we sampling soil sample before planting according to the method of the Department of Soil Science to analyze soil fertility and NPK by test kit. And this slide shows the soil samples were used to assess the initial soil fertility using NPK and soil acidity alkalinity test kit by my student. After that, that I mentioned previous, we used two cultivars of Napier grass. We used 1 month of nursery grass, Moklek and Pak Chong Wan were transplanted on August into the prepared field. And one plant per hole with a distance between plant is 1 by 1 meters for each cultivar for 3 rai or around almost half hectare. And this slide showed we make a hole and transplant plant by hand, by man or by labor. This slide show a nursery glass that we use a stem cutting and nursery plant before transplant to the field to ensure that they will grow through the experimental period. 1 month later, we remove weeds from the plot by man. No machine used in this experiment. The left side is Pak Chong Wan at 1 month old, and the right is Napier Moklek. And we also common cutting at 1 month old at a height of 15 centimeters above ground level to ensure uniformity glass growth. And then we apply basal fertilizer at a rate of 25 kilograms per rai or 4 kilograms per hectare. And each pasture was divided into 6 paddocks using electrified wire. Each paddock was 800 square meters. This slide shows a pasture outline for rotational grazing. We divide into 6 paddocks per cultivar. 1, 2, 3, 4, 5, 6 for Moklek. And we set 5 days grazing for each paddock, and then cattle move to the next paddock. Totally 30-day grazing per cycle. In the red line is the area of walkway of the cow, and we have an electric fence. This is a real photo for the electric fence, and here is Pak Chong Wan Napier grass. You can see one calf in the jungle of Napier grass. The first time that we led them to the pasture, they stunned, and they don't know what is it. It is a glass. They don't know how to bite or how to walk through the pasture because 8 months 8th month before, they eat or they always stay in the stall barn 24 hours, eat only TMR feed. And now they come to the jungle of the napier grass and they stunt, but finally they used to get used to the pasture, how to graze or how to bite the grass. This is a small narrow path, allow cattle move easily to the next paddock. Here is a walkway with electric wire or electric fence for cattle. Walk down from the pen above to the grass field in the morning. And talk about the cattle or the calf. The calf each calf was random into the treatment. We have 3 treatment. The T1 is treatment 1 is a TMR feed with a free stall and plus mineral. And T2 is a treatment 2, the calf graze Pak Chong 1. And T3, the calf graze Mok Lek Napier grass pasture. And we set the grazing time and the time to return to the stall for the both treatment. The grazing time is around in the morning 7:30 to 10 a.m. and then back to the stall at 10 a.m. until 1:30 p.m. for eat to get to get concentrate feed and water and mineral, and then go back to the pasture in around 1 o'clock, 1 p.m. to 3 p.m. and then come back to the stall and stay all night. This slide shows the T2 treatment 2 of the experiment. 3 dairy calves graze Pak Chong 1 napier grass. And here is the Mok Lek napier grass pasture. After finishing grazing at each time of each day, the calves in T2 and T3 were herded back to the house to get water and supplemented with 2 kilograms per day of concentrate feed at 21% of protein content. For grazing management, the dairy calves were grazing in a rotational graze for 5 days per paddock at a stocking rate of 6 calves per rye or almost 1 head per hectare. And we trained the calves walk to the pasture and graze 1 week before starting the experiment. The first round of grazing was 20 November to 19 December, and the second round was from 20 December to 19 January. After each grazing, no grass was cut or cleared in the field because it was in the dry season and water could not be provided. If we cut, the grass cannot regrow because it lacks of the water and the temperature is not suitable for the regrowth. And the grass left over from grazing in each paddock was left to grow for use in the next round or the next cycle. Next is data collecting. The first we collect dry matter yield of both grass by collecting grass sample before grazing in each round of 3 paddocks from 6 paddocks. I confused that why my pen. Okay, sorry. Sorry. By using a 50 by 50 centimeter sampling quadrat and cut grass at 10 centimeter above the ground. Then we weigh the fresh weight. randomly, then randomly sample again about 500 grams, dry at 60 degrees Celsius for 24 hours or until the weight is constant. Then calculate the moisture content and dry matter of glass to calculate the yield per area. Plant height and plant length. We use a metal stick to measure from the ground to the highest point of the glass, and the glass length in the below photo was measured by cutting glass 10 centimeter above ground and laying it flat on the ground by gathering all leaves pointing upwards, then measure from the cut part to the longest tip is the glass length. And tiller density was measured by counting the tiller that were green and not dry. For the remaining fresh glass sample, we separate the leaves. We use leaf blade only, and stem, dead part, peduncle, and inflorescence cut into small pieces with scissors, dry in a hot air oven for use as a sample for protein content and fiber analysis in the terms of NDF, ADF, and ADL. And for the carbs, we measure body weight changes by weighing all 9 dairy carbs every 30 days to calculate ADG. And we also observe behavior in the experimental plot initially, such as grazing, behavior, sun breathing, and physical characteristics. And we also collected climatic data such as rainfall, temperature, and relative humidity to calculate the temperature and relative humidity index, or THI, according to the equation. And we also record the production cost of the dairy cows in groups. We dividing the production cost into 2 main parts. First, the cost of glass establishment, including cost of chemical fertilizers, electrical equipment, labor costs of glass planting and maintenance, and the cost of dairy cow feed, including the cost of the concentrate feed, TMR feed, and labor cost of feeding. And data analysis, all means were analyzed for variance using a randomized design for ADG, nutritional composition of glasses, and we use block design for napier grass yield. The mean values were compared using the DMRT method. Next, for the results, for climatic, how to erase my yellow line. Sorry. For the climatic condition, from the weather data in the table, it was found that the amount of rainfall during the experimental since August decreased from the previous month, but the amount increased in the September because this time is the lack of rainfall in Thailand is anomaly. And as a result, napier grass received full rainfall during the initial growth period. And the amount of rainfall began to decrease when November arrived, until very little rainfall was found in December, which is the period when dairy cows were allowed to graze the grass. And next is the THI index. THI index in the December was 71.5. That means the animals are not stressed. But in the November and and January, the THI data is above 72. It means the animals are slightly stressed. From observing their behavior in the grass plot or in the pasture, the dairy calves were grazing normally and did not show any signs of stress, especially in the afternoon. Result in the soil conditions in the experimental plot. Preliminary tests found that the soil in the plot for planting Pak Chong Wan was slightly to moderately acidic, with very low in nitrogen, very high in phosphorus, and low in potassium. The soil in the plot for planting Mok Lek was slightly acidic, with very low nitrogen and high phosphorus and low levels of potassium. The soil acidity alkalinity levels of the soil in both plots were slightly to moderately acidic, pH 5.5 to 7.0, considered suitable for grass cultivation without the need for lime improvement. While nitrogen and potassium levels were low, requiring additional nutrients by use basal fertilizers during early growth. However, no additional chemical fertilizers were applied when dairy calves were grazed on the plots, as the forage crops had already received manure and urine from the dairy calves during grazing. The table 2 shows the ADG of the calf during the grazing period. We have 2 cycles of the grazing, and the results show that rearing calf in stall barn or in group 1, 24 hours with TMR resulted in significantly better average of ADG compared to other group. In the end of the experiment, 0.7, 0.5, and 0.4. But if we focus in the second cycle, we found that the ADG is the same, 0.8, 0.7, and 0.8, indicating that the cattle getting used to grazing compared to the first round and can gain weight compared to the calf in the group 1. Table 3 show the plant height, length, and tiller density between Pak Chong Wan and Mok Lek. Note that we collect all data before grazing. It is differently significant between plant height, and length and tiller density in the cycle 1. Of course, Pak Chong Wan is a tall type, thus the height and the length are longer than Mok Lek. That is the dwarf type. But the tiller density of the Mok Lek is much better. And after grazing or in the beginning of the cycle 2 or the second cycle, both of glass had the same height and length, but difference was found in tiller density. 17 and 45 tiller density per area. Table 4 is a dry matter yield between Pak Chong Wan and Mok Lek napier grass. The dry matter yield of Pak Chong Wan is better than those in Mok Lek in cycle 1, which is mostly from the stem part, because the leaf part is the same. The stem is different significantly, and their leaf is the same. While in the second cycle is not differ in statistical analytics. The table 5 is a chemical components on dry basis between Pak Chong Wan and Mok Lek. In the first cycle, we collect before the grazing in the pasture. We focus on the crude protein content in leaf and stem of both Pak Chong Wan and Mok Lek. we found that the Mokhlek napier grass has the crude protein content in both of leaf and stem higher than in Pak Chong Wan. Pak Chong Wan, the leaf has a protein around 10 and Mokhlek at 14% of crude protein content. And you see at the stem part, the Pak Chong Wan has protein content only only 3%, while in Mokhlek stem is 7%. And in the next cycle, after grazing in the first cycle, in the pasture, it will have remain urine and manure of the cattle. Thus, I think thus the crude protein content in the field is higher compared to the first cycle. Here, the first cycle, both in Pak Chong Wan and in Mokhlek. But in Mokhlek napier grass also has a higher crude protein content compared to Pak Chong Wan, both in leaf and stem. Finally, we record the cost production, but I did not compare in statistic between the group. The first is a pasture establishment. The total of the cost is around 20,000 Thai baht. And we collect the net cost of pasture by compared to the diameter yield of the grass. In Pak Chong Wan, the diameter yield of the grass is higher than the Mokhlek napier grass. Thus, the net cost of pasture in the first time is cheaper. And compared to the feed, we collect the TMR and concentrate and labor. We found that the total baht per head per day, baht per head per day is not differ. The differ is around 10 baht per head per day. And we show the ADG of calf 0.7, 0.5, and 0.4. And finally, it can be concluded that the ADG of male dairy calves raised by feeding TMR with confined pens of the DPO resulted in better growth rate of calves than those released to graze on napier grass pasture with concentrate feed during the cold and dry seasons in Thailand. And Pak Chong Wan napier grass gave higher yield than Mokhlek napier grass, but had lower nutrition than those of the same age. Thank you so much.
Thank you, Dr. Kannika Umpuch, for the highly informative and thoughtful presentation today. We want to move to the next session, that is a question. So for all the participants who have a question, you can write it on chat box or you can ask directly to Dr. Kannika. Anyone have a question? You can write it on chat box and I will read it for you, or you can ask directly.
I want to ask.
Okay, please. Okay, Miss Purnama, please.
Good afternoon, everybody. My name is Purnama Istiharani, and I would like to say konnichiwa, sensei, arigatou gozaimasu for your guidance before. Maybe you
Oh,
didn't notice me.
thank you very much. Yeah, for your
Nice to see you
comments.
here, sensei.
Thank
And
you.
and both of your presentation are really nice and give the valuable insight for us, of course, about forage and grazing science. I noticed I would like to ask to Mrs. Kanika. Sensei, I want to ask about your research. It's really interesting. You did your research massively, start from the zero to the 100 points, so we can understand better about your research. But I want to know how long did you conduct your research? Start from your growing until you conduct and you measure the performance. And you mentioned about before that you record the stress of the calf. I want to know how did you record the stress, because if we can see the stress conditions based on the like feasible team, I'm not sure that we can measure it very well. And I want to know how far is it. And
Okay.
have you published your manuscript about this research first? Yes. And the
Uh,
last questions, the last questions,
many
I'm
questions.
sorry. The last questions maybe because I'm really interested in research about grass germplasms and plant breeding, especially forage and legumes. And so far, we have noticed that there are so many species, new varieties from Thailand, like you mentioned before in your research, such as Pak Chong 1. I don't know why you mentioned Pak Chong 1. Is there any Pak Chong 2 or something like that? Are they did they do something research in this plant breeding, I mean forage breeding, by breed naturally, or is there something like a plant breeding methods for forage? I want to know specifically. Maybe you have information about that. Thank you.
Thank you so much.
Yeah.
Your first of all, your English is very good.
Thank you so much. This is pretty nice.
And the first question is the experimental period.
Uh-huh.
I start from July to prepare the land. July, and then August plant and make a grazing time or 2 months, not 2 months, November to January. Totally July to January is my experiment period.
Okay.
And I collect all data in the before the grazing start in each cycle 2 times. The first is the start. The first is in November, and the second is the December. We collect 2 times for the class data. And the second questions.
About have you published this
Oh,
research?
yes, I'm already published, but in Thai journal.
I can picture
Yes,
now.
in Thai. Yeah, sorry.
Oh,
And
did you break down the data? I mean, or you mentioned all of start from the zero to the last experimental? You mentioned it. I mean, in the manuscript, all of the manuscript. I mean, all of the data you mentioned in all manuscript.
yes,
One manuscript. Wow,
Yeah.
very nice. Very nice. Yes, it's really
And
interesting.
the third question is the Napier Pak Chong Wan, right? The
Yes, about the breeding.
breeding Pak Chong Wan breeding plan is breed by the government of
Ah,
Thailand,
okay.
not mine. Yes.
Okay.
Now is Pak Chong Wan, only Pak Chong Wan.
Okay.
Yeah.
Also, do you have any information that they do the researcher, the government researcher, do the breeding by natural or like such as uh maybe like artificial, something like that
I
in
think
breeding?
I'm not sure, but I think
Ah,
it's conventional breeding.
conventional breeding. I see, I see. Okay, nice. Thank you so
And
much.
the fifth questions is
Yes, the stress. How did you measure? How
the
did you
spread.
measure the experimental design? The experimental for the calf. You mentioned that
Uh,
they're not stressed. How did you measure this
the
this
first
this?
is the THI index. The
Okay.
first is THI index. The second is I observe by eyes. I
Oh,
look their
observation.
grass all day and note and record the behavior, the breathing during the noon or in the afternoon. And for the feces that I did not mention, the feces is normal. The dung is normal, except the feces of the cow or the cattle that eat TM that receive TMR. The dung is like a water with a smell like a silage.
Oh, okay. Makes sense.
We,
Makes sense.
we, we only observe by eyes.
Oh, I see. Really nice. Really interesting research. Yes, I think that's
Thank
all
you.
from me. I hope someday we can collaborate in research because I think we have the same research interest. So maybe later or someday we can perform research together. Thank you.
Oh, you're welcome.
Yes, thank you so much.
Thank you.
Thank you.
Thank you, Mrs. Purnama, and thank you also to Dr. Kaninka for your response. Because we still have a time, maybe to all other participants have a question, you can ask directly to Dr. Kaninka. There is any question? Okay, Mr. Wakano, please.
Yes, thank you very much. Good afternoon to everyone, and also especially the speaker, Miss Dr. Kanika. I hope that my voice is clear because this is right now in my place there are heavy rain, which is a miracle for us. As I mentioned to Prof. Yasuyuki before, that we are facing longer dry season, and now today we have a heavy rain. Alhamdulillah. Okay. Maybe I'll make it quick for Miss Dr. Kanika. On your presentation that you mentioned for the nutritional content of between Muaklek grass and Pak Chong Wan is Muaklek grass is better on nutritional content than Pak Chong Wan. But in your application to the cattle, based on your data, I hope I am not wrong to see the data. The average daily gain of the cattle that graze on Muaklek grass, Muaklek field is lower than Pak Chong Wan. Could you please explain that why could that happen to the cattle? Thank you very much, Mr. Kanika.
I will share slide.
Okay. Yeah.
Wait, any? Okay.
Yes.
Yes. Function 1, average 0.5, and more like Napier grass, average in
Yeah.
the average is the same. In the same.
Oh, it's the same.
The
Oh,
the average is
the
come
average
from
is the same.
the first and the second class and by two and the same, but yes, the same in all
In
period. Yes, yes, yes,
statistically, it's the same.
yes,
Yeah.
yes.
Oh, okay. So I think I misunderstood the data. I'm so sorry for my mistake, Mr.
It's okay.
Miss Kannika. So I just want to make clear that I'm curious because more like grass is have higher nutritional content, and then average daily gain of the Pak Chong one is higher based on the number, but I didn't see the statistically.
Okay.
I'm so sorry for my mistake.
It's okay.
Thank you very much for Miss Kanika and Miss Isma.
Okay, thank you for the question, and also thank you to Dr. Kaninka for your response. And we in the end our season today. Before we officially close the event, I would like to present a certificate of appreciation to our speaker today. Let me share screen first, and it officially given to you. Okay, this is certificate to Professor Yasuyuki Insight to receive a certificate in recognition of his insightful presentation on Grassland Science today. Thank you for Prof. Yasuyuki Ishii for your sharing valuable knowledge with us today.
Thank you very much for this nice certificate. I'm very proud of receiving this certificate at this meeting.
Okay, the committee will send you also this certificate to you directly. Okay, the next one, I would like to present a certificate appreciation to Dr. Kannika Umpuch for their excellent presentation on forage crops. Your expertise has greatly contributed to today's season, and we deeply grateful to hear your presentation today.
Thank you so much.
Okay, also the committee will send you this certificate. And before we close our event today, I hope all the participants can turn on the camera so we can take a picture together. For all the participants, maybe you can turn on your camera and we will take a picture together. The committee, please, can you help us to take a picture? Anyone? Okay, I'm also will help by my laptop. So I will count it 1, 2, 3. Once more. 1, 2, 3. Okay, this is the end our season today. For all the participants, thank you for coming and joining to our meeting today. We look forward to welcome you back tomorrow. We still have a season for tomorrow. And see you next day. Thank you.
Arigato gozaimashita, Ishii sensei.
Thank you very much. It's a quite
Dr. Kannika, thank you.
Nice chance. Yeah.
Thank you, Prof. Ishii. Thank you for your nice
Ah, Thank you very much.
Next year I
for
went to
playing.
Miyazaki again. I will go to Miyazaki again, Ishii
Ah,
Sensei.
yeah, yeah. Please come. Please
Okay,
come to
thank you very
Miyazaki.
much.
Sometimes. Thank you very much.
You're welcome. You're welcome.
you, Dr. Kannika.
Thank you, Reni-san.
See you.
See you later.
Thank you, arigato, sensei, Prof.
ありがとうございます。Thank you very much, Dr. Kannika. I'm going out from this room. Thank you very much.
はい、ありがとうございます、先生。
Maesty, thank you very much.
はい、ありがとう。
Izin lift. Siti mau ke ruangan?
Iya, sensei.
Thank you. See you there.
Yeah. Yeah, catch you up. Yes,